I feel like you were right.
Oh, my homework 3. That's homework 3. No. Homework 3.
Good afternoon. Let me solve one quick example on the rigid body that we derive the Newton's force equation. We end up with this matrix, which is representing Newton's law equation. So suppose for this one, theta 2 is 30 and theta dot 2 is 20 radian per second, and the angular acceleration for input link is 15. This is R2. R2 is 10 inch. And RG2 is going to be at the middle. So it's going to be 5 inch. The weight of this rigid body is 4 pounds. And the mass moment of inertia is 0.08 pound inch second square. The force in x direction, Fpx, is 40 pounds, and Fpy is 0. Fpy is 0 pounds. So we don't have any force in y direction. We would like to know what would be the force coming from ground to this thing in x and y direction, and how much torque do we need to run the link. So what we need to do, we need to set up this matrix form, which is 1, 0, 0, 0, 1, 0. RC2 is 5 inch times negative. It was RG2 sine of theta 2, RG2 cosine of theta 2, and 1 F1 2x, F1 2y, and Ts multiplied by acceleration of center of gravity in x direction is going to be negative RG2 omega 2 squared cosine of theta 2. I derived it on yesterday's class, minus RG2 alpha 2 sine of theta 2. RG2 is 5, omega 2 is 20, and theta 2 is 30 degrees. So you have these terms, also you will end up to negative 1769. And ADY negative 9, negative 5. So, yeah, on the right side, I need to know what would be the mass. What would be the mass of link to, I provided the weight, which is 4 pounds. You should change it to the mass. So the mass of 2 would be the weight divided by the acceleration, which is 4 divided by 386. You will get 0.0104 plus. Don't use 4 pounds in this equation. You have to deal with the weight, with the mass. Sorry. So this is 1 point. Make sure that you use times negative 1769 minus FPX. FPX is 40, negative 40. Second, 0.014. Acceleration in y direction. FPY is 0. I is given, mass moment of inertia, 0.08 times 15, which is alpha. FPY is 0. It's going to get 0 value. Negative times negative is going to be positive. So I get positive 40 times 15 times RPY, or this guy, which is the RG2. It's going to be 5, not 15, sine of theta 2, which is 10. So if you solve for unknown, I will find f to x, f1 to x is negative 57.67, f1 to y is negative 58.4, and the required torque at this time is 205.1. Sorry, 204.7 pound inch. So I would like to talk about the term that you might see in the book or in the homework, shaking force. The force applied to link 2 coming from the ground is F1 to X and F1 to Y. So if I ask you what will be the magnitude of the force coming from link 1 to 2, we can say F1 to X squared plus F1 to Y squared. It's going to give you the magnitude of the force, and we call this shaking force. Because the reaction of that force is going to apply to the ground, we would like to know how much force is going to be transmitted to the ground. It's going to be F21. The magnitude is going to be the same, but the direction of the force will be in opposite direction. Action and reaction in Newton's law. 1 to X is going to change to F21, and 1 to Y is going to change to F21Y. But the magnitude will be the same, because negative sign square is going to be positive, negative sign square is going to be positive. So the shaking force is going to be 59.2 2 pounds. Any question on this example before we move on 4 bar? All right, 4 bar mechanism, it's gonna be, the process is gonna be line, but straightforward. So stop me if you have any question on that. So what we derived, it was a single link in pure rotation. But it's going to be the first link on the 4 bar mechanism. We are going to do the same process for all 3 moving links. And then we are going to get 9 equations in the system of equations. It's going to be a very long process, but the process would be the same for all 3 moving links. So let's look at them one by one. These are the parameters that we are going to use. Let me draw them here. I'm going to use them on this board. R2, R3, R4 are the link length. Location of center of gravity for each link. RG2, RG3, and RG4. This one and this one, all are given. RG2, RG3, and RG4. And I assume that the center of gravity are located at the midpoint, just to simplify that. But if it's not, it should be provided. Where is the center of gravity location? The mass of link 2, link 3, and link 4 are given. We know how much would be the mass. If it's weight, we should convert to the mass. And also mass moment of inertia for all 3 moving links, I2, I3, I4, with respect to center of gravity. We have performed kinematic analysis, displacement, velocity, and acceleration. We know theta 2, theta 3, and theta 4, as well as omega 3, omega 2, omega 3, omega 4. Angular accelerations they have been calculated by acceleration analysis. And also we know what would be the acceleration of center of gravity for link 2, link 3, and link 4. So A, center of gravity of link 2 in x direction, A, center of gravity for link 2 in y direction, A, center of gravity for link 3 in x direction and y direction, are should be calculated before we do anything. Any questions so far? These are the given data. They are either given or they have been calculated by kinematic analysis. All right. what we expect. Single moving link has three equations. Three equations meaning force in x direction equals to the mass times acceleration in y direction, and torque. I'm talking about this. Sigma f in x direction would be mass times acceleration in x. Sigma f in y direction, mass acceleration in y direction, and summation of the torque is going to be I with respect to the center of gravity times the alpha. So each link is going to provide three equations. Three moving links, we are going to get 9 equations, and we are going to have 9 unknowns as well. These are the force convention that we are going to use. Fig meaning force coming from link I applied to link J. Ij meaning force coming from link I applied to link J. Fij is equals to negative Fji because of action and reaction. So whatever force link 1 is applying to link 2, it's going to be in the opposite direction of the force coming from link 2 applied to link 1. So F12, it's going to be negative F21. And force F12 has two components in x and y, so it's going to be negative of x component and y component of F21. Good? All right, let's start with first link. Free body diagram of link 2. Link 2 here. I'm gonna go one by one. Don't get lost. Link 2 has 2 points. One connecting to ground, which is link 1, another connecting to link 3 that we have over there. This is coming from link 1. F12 applied to this, F12 in 1. F1, F at 3 to 2x, F3 to 1. Center of gravity is at the middle, and we have R2, and we have input torque, sorry. We derived this equation yesterday. I'm just rewriting again. Summation of the force in x direction, F1 to x, F3 to x, is mass of link 2, acceleration of center of gravity of link 2 in x direction. A, G2 in x. Let me remove up, get it out. C, G2x, F1 to y plus F3 to y equals to mass of link 2, acceleration of center of gravity times y, input torque plus, we talked about this force times this distance is making counterclockwise. So it's going to be positive. F1 to x times Rg2 times sine of theta 2. Torque due to this force. Torque due to this force is going to be clockwise, negative Rg2 cosine of theta 2. These two forces also making torque. We discussed about them. R2 minus Rg2 will be this length. This force times this distance, which is R2 minus Rg2 times sine of theta 2, is making torque clockwise, negative is due to that force times the length. This is the R2 minus RG2 times sine of theta, so it's going to be perpendicular. So minus and plus last one F3 to R2 minus RG2 cosine. And this is going to be equals to the central mass moment of inertia of link 2 IG2 times alpha 2 or theta double dot. This is for link 2. We just did it yesterday, something like this. I wrote the free body diagram of link 2. Now I'm going to move on link 3. Question on this. Link 3. I'm going to draw the free body diagram. So the forces coming from link 2 to link 3 should be written as F23, F23x and F23y. I assume it's going to be in this direction. And also from link 4, since we have connection with link 4, we have these two forces, F4 to 3x, F4 to 3y. We don't have any external torque. And center of gravity is going to be here, RG3. Rewrite the force equation. Summation of the force in x direction, F23 in x plus F43 in x equals to mass of link 3 times acceleration of G3 in x direction. These two are in x direction, and these two are in y. The torque, it might be, it's going to be same as this one, except we don't have TS, we don't have any external torque. I will start from this force. It's similar to link 2. This force times this distance, the vertical distance, is making torque in counterclockwise. This is the magnitude of the force. The distance, the vertical distance will be RG3 sine of theta 3, sorry. It's going to be F23x RG3 sine of theta 3. This force making clockwise, so I put negative F23y RG3 cosine of theta 3. This force times this distance is making clockwise, so I put negative F43 times R3 minus RG3 sine of theta 3, and this force times this distance is making moment counterclockwise, positive. F43y RG3 minus, sorry, R3 minus RG3 cosine of theta 3. So 3 equations for link 3. So far I got 6 equations. Any question on this? Before we move on, the last thing. This is the last thing. Suppose the angle of theta 4, just the way that I have drawn the mechanism, theta 4 is this one, but this is gonna, if you just extend this, it has in theta 4, and link theta 4 is gonna rotate it at this orientation. It doesn't change the problem, but if I draw this here, link 4 is connected to the ground, so 2 forces coming from the ground. F1 for X, F1 for Y. This point has been connected to link 3, so we are going to have F3 for X, F3 for Y. And this is the center of gravity for link 4, R of G4. Summation of forces. I have these 2 forces in X direction, F1 for X plus F3 for X. It's going to be mass of link 4, M4, times acceleration of center of gravity of link 4 in X direction. F1 for Y plus F3 for Y, M4 center of gravity of link 4 in Y direction. And last equation is going to give us the torque. This force times the vertical distance is making counterclockwise. This force is making clockwise, so it's going to be negative. And similar to link 2 and 3, I can write the moment or the torque that these 2 forces making about center of gravity. And right hand side will be I G4 times alpha. This is the last. So I derived all 9 equations so far. I have all 9 equations here. The first 3 equations you can see here. Second set of equations are here. and the last 3 equations that we have over here. We got 9 equations. R unknown, let's count. F1 to x, 1. 3 to x, 2. 1 to y, 3, 4, 5. Here we have 2, 3x. I'm not going to count it as a new variable because 3, 2 is going to be negative of 2, 3. So I'm going to replace that. Instead of using 2, 3, I'm going to use negative f3, 2. So for x and y. So far 1, 2, 3, 4, 5. I don't count this. 4, 3. 1, 2, 3, 4, 5, 6, 7. 4, 3 here. 4, 3 y. 7. Yeah. 5, 6, 7. And here f1, 4, 8. And f1, 4 y is 9. And that's all. I'm gonna talk about the matrix form, but before I go through that, any question on this? I'll keep this slide and I'll get rid of this equation because I need the entire of the board to write this system of equation in matrix. We have 9 equations. So I should have the variables are f1 to x, f1 to y, ts, that's the torque that we need, f3 to x, f3 to y, here, f4 3x, in 7 I have f4 3y, and f4 1x, f4 1y. So first I should form my variables. I have 9 equations, so the matrix is going to be 9 by 9. Each row corresponding to each equation. All right, first row, I'm going to look at the first equation and first variable. The coefficient of f1, 2 in the first equation is 1. I put 1. Second variable is f1 to y. There is no f1 to y. I put 0. Third variable is ts. There is no ts on the first equation. 0. f3 to x. We have 1 f3 to x with a coefficient of 1. I put 1 and the rest would be 0. There is no other thing. Right hand side is the constant part m2 ag to x. Second equation, we don't have f1 to x, we have f1 to y, 1, 0, 0. Number 5, 1, 2, 3, 4, 5. We have f3 to y. And no other. Third equation, the coefficient of f1 to x is rg2 sine of theta 2. Just to save space, I'm just writing rg2 s theta 2, meaning rg2 sine of theta 2. The coefficient of f1 to y is negative rg2 cosine. Negative rg2 cosine. I note by the c. Negative rg2 c theta 2. TS has the coefficient of 1. I plug in 1. Number 4. 1, 2, 3, 4. 3 to x. 3 to x has this. Negative r2 minus rg2 sine of theta 2. One, two, three, four, 5. Coefficient of f3 to y is positive of this and cosine. f43, we don't have any terms left. 1, 2, 3, 4. And equation 4. Here, f1 to x is 0, f1 to y is 0, ts we don't have. f3 to x. Here I have f23. The variable should be changed to f32, so it's going to be negative 1. f23 is negative f32. Second one is negative f3 to y we don't have. f43, we have f43, and the next 3 would be 0. Here I'm going to get 0, 0, 0, 0. f23, here I have f32. 23 should be changed to 32, negative 0, negative 1, sorry. Equation 6, which is this guy. This is 0, this is 0, this is 0, up to this. 1, 2, 3, 4. 1, 2, 3. Here, we have f23. Here I have f32. Put the negative behind this. It's got to be negative rg3 sine of theta 3. We have f23y, here we have f32y, it's going to be negative, negative times negative, positive. So rg3 cosine of theta 3. f43, 43 is going to have a coefficient here, negative r3 minus rg3 sine of theta 3. And last term is going to be for this guy, R3 minus RG3 cosine of theta, and 2, 0 here. Equation 7, 0, 0, 0, 0, 0, up to F3, 4. 1, 2, 3, 4. 1, 2, 3, 4, up to here. So number 6. 1, 2, 3, 4, 5, 6. And the coefficient of F34 is 1, but here we have F43, negative 1. We don't have F43y, it's going to be 0. F41, here we have F14. So let me change it to F1. It's going to be positive 1 and 0. And 0, 0, 0, 0, 0, 0, negative 1, 0, positive 1. And last equation, F1, we have F34, 1, 2, 3, 4, from here. F43, here we have F34. I put a negative behind that, negative times negative positive. It's going to be R4 minus RG4 sine of theta 4. This guy is going to be negative R4 minus RG4 cosine of theta 4. Coefficient of F14 is positive RG4 sine of theta 4, and last term is positive RG4 cosine of theta 4. Negative. Let me write the right hand side and go to this. This one is going to be M2 AG2Y. This equation has RG2 alpha 2. This equation has M3 AG3X, M3 AG3Y. Equation number 6, IG3 alpha 3, M4 AG4X, M4 AG4Y, and IG4 alpha 4. And this is what we derive. Let's check. The first row is the same, 1, 0, 0, 1, the rest is 0, 0, 1, 0, 0, 1, and the rest 0. RG2 sine, negative RG2 cosine, 1, negative R2 minus RG2 sine, positive R2 minus RG2 cosine. 0, 0, 0, negative 1, 0, 1, the rest is 0. 4, 0, negative 1, underneath this. 4, 0, negative 1, 0, 1, 2, 0. 3, 0, negative RG3 sine, positive RG3 cosine, negative R3 minus RG3 sine, and positive R3 minus RG3. 1, 2, 3, 4, 5, 0, negative 1, 0, 1, 0. And here we have negative 1, 0, positive 1. And this is the last row, which is going to be the same as this one. So you are given, or you have calculated the terms that you can see on the coefficient matrix. This is a coefficient matrix, and this is a constant matrix. So you have everything that you need by performing the kinematics analysis. So you have acceleration of center of gravity in X, acceleration of center of gravity in Y, and for link 4 and link 3. You have mass momentum inertia, you already know alpha 2, alpha 3, and alpha 4. Then you can do the force analysis and find this way. Now, After you find them, if I ask you what would be the shaking force applied to link 2, shaking force is F12. We can say F12x squared plus F12y squared. What would be the shaking force applied to the link 4? So you can do that.
Will this be on the test?
Not similar to this, but let me go over, because I'm already asking you to do as a homework problem. I'm not asking the same at the exam. As I said, it's my favorite homework because it has everything that you have done so far. It's a forward mechanism that we have right here. You have done displacement, velocity, and acceleration analysis in homework 4, 7, and 8, which is due today. We assume that the input link is rotating at a constant speed, meaning alpha 2 is 0. We would like to do for the open mode, for first mode, when I'm saying open mode, meaning that all 3 links are in the same side. We would like to do the force analysis for all input angles from 0 to 360 in a step length of 5 degrees. And we would like to find shaking force applied to the ground at joint O2 and O4, I'm looking for these two, versus the input angle. So I would like to see a graph, here theta, here F12. Theta going from 0 to 360, you find me the shaking force. And find the maximum shaking force at point O2 and O4. That's what would be the maximum value for the shaking force. Also find the input torque required to derive the mechanism. So this time plot torque versus theta. And tell me at which angle we are going to need the maximum torque. Theta for torque maximum. What is that? Torque. And these are the information that I provided. The weights are in pounds. You have to change it to the mass. And only one problem, it has 40 credits.
Question. So we're making the assumption that the center of gravity
At the middle.
is the middle.
Yeah.
Do we need to find the theta for torque max from the values that we checked, or the exact value that it has?
No, you have, after you plot this, you know at which theta we are going to have the maximum torque.
Okay.
So you need to perform, you need to use the loop to 360 divided by 5. It's going to be 72. You are going to solve this system of equations 72 times by the loop. And in each iteration, you will get a t. You are going to plot t versus theta for that, for all 72 points. If you plot them, you will get something like this. Tell me what will be the maximum torque at which angle. Any other question? So next week we are going to start kinematic synthesis. I will collect the homework there.